Hello everybody, my name is Fernando. I'm a PhD student in civil engineering at Oregon State University. On this video I'm going to show you the process it takes for LIDAR scanning of a mass timber structure using two different devices, the Leica RTC360 and the Leica P50. I will be uploading more content later explaining more in detail the parts of the experiment, but basically it consists of a real-scale 3-story mass timber building that is going to be tested laterally to determine its seismic performance. As you can see on this image, there are shear walls in both directions that have different functions, being the UFP wall the one that is going to be tested on the first phase. The building is also formed with mass timber diaphragms and it is located inside the Emerson laboratory in the College of Forestry at OSU. Before scanning the building using the LIDAR devices, it was necessary to perform a survey of the laboratory and the building specimen using a total station. This is important because we will need to locate the cloud points resulting from the LIDAR scanning in a reference 3D space, being able to detect differences in the lateral deformations for future scans once the lateral test is performed. So on this part of the video, we set up the control points in different parts of the laboratory in places we know are not going to be affected or moved, like in concrete and timber columns. Another important part of the process is to have target points distributed around and inside the specimen building. So when the post-processing is being done, we will have these constraint points that will join the cloud points from different scans. So for this, we use sticker paper with black and white colors that can be detected later by the algorithm. Once the targets were located around the experiment, it was time to start the survey with the total station. We set up the coordinate 0 right below the total station, as you can see in the black circle, and it was necessary to level the robot at the same time, to center it using the laser inside control point 1.
All these things are safe. Is it good?
After some small adjustments, the total station was ready to start the survey of every control point and every target. This part of the process needs to be as precise as possible so the error in the registration can be in the acceptable range.
Maybe our initials.
Yeah. Every point registered by the survey needed to have its own name, as shown in every target. So this is the input requested by the total station, as you can see in this part of the video.
GA.
Everything was ready to start looking around the first point of the total station, so we detected the control points first and then the targets that were visible.
You want to see it? Yeah.
An important quality control technique in the survey is letting the robot find previously registered points on its own. On this part you can see how it looks for point A1 being as accurate as expected. The total station was then moved inside the building to have a complete survey of every target, finishing this part of the process. The next day, it was time for the LiDAR scanning to begin. The first device we used was the RTC360, which was proportioned by the NERI Natural Hazards Reconnaissance Rapid Facility. This device has better resolution than the BLK360. It's highly portable and really intuitive to use. It can measure up to 2 million points per second, and with the maximum resolution with pictures included, it can finish one scan under a 3-minute lapse. Another advantage of this device is that it requires to have several scans close from each other, so upper registration can be achieved without manual intervention. Right now we're using the RTC360 on the back. It's a little bit noisy, but it's faster than the P50 that we're going to use later. So we're planning to have like a 3D model for the building LiDARs. We're using the LiDAR scanning. Yeah, that's it. Exciting. Yeah.
Music bed. Music bed. Scan an image, 15 minutes. The resolution is right here. We're doing 1 centimeter at 50 meters. For images, warm light, image resolution, we're going to stick with the best quality. We're not going to do any filters, and for the range, we're going to keep it at the lowest one, which is 120. Okay. If I go,
this is just for the first.
For the first station. As far as setup, oops, let me go back. Continue. I think we're good here, target. Here's the parameters we put in for temperature and pressure. Okay, I believe we are good to go, and this is the name. Yes.
Okay.
Oh,
Do you want to
off a
keep
little
it
bit.
below 10 or?
Yeah, it looks like it moved on us. That's good.
Okay.
Plus or minus 10. We don't need that, and we don't need that. Okay. Gonna start it?
Yep.
Here's the name.
What you just saw was the input for the Leica P50 laser scan. This device has a longer distance range with high resolution compared to the RTC360, so it was very useful to capture the outside faces of the building. Nevertheless, the time for each scan with pictures included was around 15 minutes each, so we just considered to use it in less locations in the building. This is the last part of the video. I hope you have enjoyed this new content since LIDAR is a really cool technology that can be applied in different ways. I'll be showing the 3D model in the next part with the registration process in Cyclone, so you can see the final results from all of these scans in a 3D space. As I said in the beginning, I will upload more content on this project since it has a lot to explore. Please subscribe and comment your thoughts on this technology and what do you think it can be used in the future in structural engineering. I want to thank our research team and the LIDAR team. I'll see you in the next video. Bye.